Today, Maths at Home Studios brings you surface area. We have so far looked at two-dimensional shapes, finding the area of two-dimensional shapes like squares, triangles, circles with little holes in them. Surface area is dealing with three-dimensional shapes, and the surface area of a three-dimensional shape is the sum of the areas of all of its surfaces. So this particular shape has got 6 surfaces, and if I wanted to find its surface area, I would find the area of each face and I would add those together to get the surface area. Now we're finding the surface area of prisms, and a prism is a three-dimensional shape that has congruent ends. That means that they're identical in shape and size, but they're also parallel. So parallel congruent ends, and the rest of the sides are going to be rectangles, no matter what shape the end is. And we name it after the end. So this is a rectangular prism. This one is a triangular prism. I've got it all cut open here. It has 2 identical triangular ends, and the sides are all rectangles. The other sides, the other faces are all rectangles. And that one can go there as well. And then we've got this one, which has got, which I'm going to call a prism. I know a lot of maths people would tell you that's not a prism. It's got a circle at each end, perfect circles I might add. Identical ends, parallel ends, and this side, if we opened it up, you can see that it is actually a rectangle. So the 2 circles and the rectangle. So to find the area, the surface area of this shape, I would find the area of each of those ends and then the area of that rectangle, and I would add those together. And I'll just show you what the other ones look like when you open them up. There's a couple of ways to find surface area, and one of them is to draw the folded out shape. So you can't actually always fold them out, but you can draw a picture of them folded out, and this is called a net of the shape. I love how maths just pulls these words out of the English dictionary and gives them a new meaning. But this is called the net of a triangular prism. And you can see the 2 triangles, and you can see the 3 separate rectangles. And this one, that open, give me a sec. Emergency mustache kit. There we go, opened out, and you can see that there are the 2 ends that are the same, and then there's the 4 different rectangles, and in fact they're not different rectangles at all. There's 2 pairs. There's 2 that are that shape and 2 that are that shape, and that we're going to use that idea to help us find the surface area. We're going to find the area of this rectangle, and there's 2 of those. We'll find the area of the green one, and there's 2 of those, and then we'll find the area of the yellow one, and there's 2 of those. Now we're going to use formulas. We've got different formula for each of those shapes. We've got a different formula for each of those shapes, and I'll talk you through one of each of those. And then for year 10s, you need to be able to work with any kind of prism. So I'm going to talk you through finding the one formula that's going to find the surface area of any kind of prism, even a moustache-shaped prism. All right, that'll do for now, and we'll have a look at rectangular prisms in a moment. Here we go, surface area of a rectangular prism. Here's a picture of your prism, and I've also drawn the net for you. And I should probably put the numbers into the net as well. This is the length, which is 5 meters. I've got this one here is 4 meters, and this one is 6 meters. And you could go around the whole thing drawing all the dimensions in if you wanted to. Why did that disappear? Okay, here is the formula. Total surface area equals 2 lots of the length times the width, plus 2 lots of the width times the height, plus 2 lots of the length times the height. Now I just go up to this shape and I go, this one I'm going to call L. It doesn't matter which one's which. This one I'm going to call W, and this one I'm going to call H. So that each of your different dimensions, so you've got that dimension there, that dimension there, and then that dimension, which is the height. Each of your different dimensions is, in this case, is a different size. So as long as you give one letter to each of those dimensions, you can just go straight to your formula and write down 2 lots of. Now L is 5 and W is 6. 5 6 is a 30. WH. W is 6, H is 4, 6 4s are 24. And here we've got LH, and L is 5, H is 4, 5 4s are 20. And then we double that, of course, because there's 2 of each of those rectangles. And you can look at the net over here. We've got a 5 by 6 rectangle, which is our 30 here. We've got a 4 by 6 rectangle, which is the green ones. That's 24. And then we've got our 5 by 4 rectangle here, the 2 blue ones, and that's 20. So we add that all together, multiply it by 2. 30 plus 20, that's 50. That makes it 74. 2 lots of 74. Put the units in there. And that comes to 148 meters squared. Now you know that this is meters squared. It's a 3-dimensional shape, but you're folding it out flat and finding the area of the surface. So it is, the units are square meters. So you write the formula, put in the numbers, do the sum, and draw the net for each of the shapes.